we are continuing on with absolute value equations, and we're just basically going to continue doing some practice and reinforce these concepts. So we should really focus again on what is the main idea of absolute value equations. Well, we want to undo the absolute value. So what does undoing look like? Well, one of the models that we look at is the function model, the function flowchart. And the way that absolute value works is as we put in positives, it just comes positive. As we put in negatives, it comes out positive. So we're going to solve absolute value. So solving is the opposite of calculating. So for solving, we are going to go in this direction. So what that means is we can only have positive absolute value, positive numbers that input. And when we solve, we have to consider the two possibilities. There are positive and negative possibilities when we undo the absolute value. So that's the main idea. So when we look at an equation like this, we want to consider this equation, and we want to ask ourselves, well, there's two scenarios where where we have the inside positive domain. Okay, and that's going to be where 3 minus 2x is going to equal positive 9. Okay? And we have the negative domain, where the inside 3 minus 2x would be equal to negative 9. Okay? And then we solve those two scenarios. So as we solve this one here, we're going to add or subtract 3 from both sides. Divide by negative 2, and so one solution is negative 3. We can solve the negative version. Again, we're subtracting 3 from both sides. We're going to divide by negative 2, and we get an answer of positive 6. So we have two solutions. Now, because of the shape of the absolute value functions, we have to make sure that the solutions are not extraneous. So the easiest way, and there are other ways based on the domain, but we're just going to do a substitution to do this, to check our answer for extraneous solutions. We're going to test. We're going to test x equals negative 3. When x equals negative 3, we're going to end up with 3 minus negative 6. So minus negative 6 is 9. So we get absolute value of 9 equals 9. Yeah, that's okay. So that solution is perfectly okay. We'll test x equals 6, and we end up with 3 minus 12 is negative 9. Absolute value equals 9. Again, that's okay. So these two solutions are perfectly valid solutions. They are not extraneous. Okay. Now, we can actually use the domain, and since we do need to know the domain anyways, we can actually use a domain to help us establish solutions. And we did this before. The domain is a little bit more complicated to do than just testing, but there will be situations where we cannot just test the numbers anymore. Okay, so we should maybe look at how the domain can determine extraneous solutions. So here, if I just write that, I'm just going to move this over to the side. So here, if we actually look at the domain of this function, the domain of this is when x is equal to or less than 1.5. So when x is less than or equal to 3 over 2, that's when this absolute value is valid, okay, when it's positive. Okay, so it's positive for those values, and it is valid for that domain, okay, when we take away the absolute value. So this is valid for x is less than. So as long as it's less than, it's going to give us positive numbers on this side. And if we compare this domain restriction with our solution, well, our solution fits inside this domain, because if we look at our domain, this is 1.5, and our domain is from here this way. Our solution is at negative 3. Check, that's okay. So compared to our domain, this domain works for this solution. Okay, so we want to be able to know when this domain is valid. So this domain is going to be valid when x is, actually I should make it not equal to. Okay, so when x is bigger than 1.5, okay, this will be equal to a negative number. Okay, so then we get our negative domain. So our domain for this portion of the piecewise function is going to be when x is greater than 1.5. Okay, so it's going to be, that's our domain. Our solution is at 6. Okay, it fits inside the domain, so it is a valid solution for this particular domain for this function. Okay, so this function is valid for this domain. Our solution is within the domain. It is a valid solution. Same with here. For this function, when we take away the piecewise function, so it's for this part of the piecewise function, this is our domain. The solution falls within the domain, so that is perfectly valid solution. Okay, so this is probably not at this point our primary way of determining extraneous solutions. Testing is again going to be a lot easier. Okay, but this is how we can use our domain to determine whether the solutions are extraneous or not.